Hey everyone, welcome to the live stream today. We are talking about connecting your power system safely and efficiently. And if you're watching this video, it's because we have been putting together a blog post on this. So it hasn't come out yet, but if you're watching this video, you probably, we might actually have this article ready. Anyway, we have an article. We're gonna go over tools and all kinds of stuff like that for electrical systems and how to do that in your van. But today's video is answering one in particular question on the article, which is connecting your power system safely and efficiently. And we're going to go over the following items in today's video. We're going to try to keep everything nice and short. So we're going to have one part is, so part one you could call it, is wiring your power system safely. We're going to talk about proper fuses, proper wire gauge, proper wire and component shielding. You may not have heard that before in kind of the van world, but it's important, so we'll talk about it. And then the second part is going to be wiring your power system efficiently. So this is going to talk about wire length, wire location, which can affect voltage drop if your power cable is too long. And then to ferrule or not to ferrule. And I spelled that wrong, so let's fix that. R-R-U-L-E. That's a very weird word. Okay, if you don't know what a wire ferrule is, I'll explain that too. If you have any questions or want to go deeper into these stuff that's not covered in the next part of this video, put that in the comments and I'll be happy to answer them. We're going to be using the help of my little drawing over here. So let me move my face into this corner. So let's see, here we go. So I've got this drawing of a simple circuit. It is very simple. So yours might be more complex or might be a little bit different, but the basics of safety and proper fusing is going to be displayed here, as well as how wire length, I'm going to give you an example of how wire length messed up and gave some false errors on a 12-volt fridge that I had installed. So lesson learned from that example. And then we'll be referencing the camera inside the van. We're going to be talking about the Victron Links distributor, and we're going to use it as an example of how these different items in the van, of the one behind me right here, is properly fused. So if you're doing this, if you're new to van electrical components and stuff like that, it can be pretty overwhelming if you've never messed with it before. The good news is 12 volts is, depending on how you're approaching it, is not that dangerous. It's not like household power where you're going to get electrocuted if you touch both wires. The voltage is lower, however, typically the current is higher, especially if you're running inverters and stuff like that. So we're going to stay to the basics, really basic in this quick live stream. And we're going to start off with this because I think it's an easy way for a real world example for you guys to see. So I'm going to go into the van. I'm going to point out what this is, what you're looking at, so when I reference back to it, you're not confused. So let's hop over here in the van. And so what we have here is, this is the Links distributor cover. This is probably out of focus, but it's okay. So this cover goes on here, and that's part of our protection so nothing touches this and shorts. Typically in a van, you're going to have a panel over here. It might be made out of wood or something like that, but for some reason, if you had something that was metal or could come in contact with these terminals, you're going to want to protect it. Now, what this is I always call it a glorified bus bar. So it's a one bar here for your positive and one bar here for your negative. If you go online, you look at a bus bar, it's usually just a bar with 4 post terminals and allows you to have one positive come in from your battery, supply power to a couple devices, and then you'll have another one maybe off over here to the side. It's the negative one, and that's going to help you ground everything. Nice thing about the, not sponsored, but nice thing about this Lynx distributor is that this makes it very convenient. It's a little expensive. It's usually around like $200 for this unit on Amazon. But it's nice because it's all put together. It's insulated really well, which means, you know, there's separation between the negative and positive, so stuff doesn't short. There's a lot of plastic and stuff like that that keeps it safe. And you get 4 circuits, and these are usually your main high amp circuits. So in here, what we're looking at is our first circuit is our this is our Dometic AC, and the quickest way to find out how to size a circuit properly is reference the manual, the manufacturer's manual on the product that you have. It's usually in the installation manual. So this one recommends an 80 amp fuse. We have an 80 amp fuse. Next we have our Renogy 3000 watt inverter charger. A 300 amp fuse is recommended for it. And then finally we have 2 more down here. That's our Renogy DC to DC combo chargers. And so this is pulling power out, and this is putting power in. And we have this fused at 60 amps. So this is actually not going into the system. What happens is the wire comes here, it's fused, and then goes into the system. And the whole goal of let me turn my camera back on. I knew I'd run out of time here with this camera. All right, how are we looking? Let's see. It'll come back on here in just a second. There we go. So the main thing that we want to do here is the fuses are protecting the wire. That's their main job. It also protects the device because by protecting the wire first, we don't want to overload the wire. The wire is typically sized, or it should be sized, for whatever component that you're using. And so they kind of work hand in hand so that the fuse is rated for the wire, and then the wire is rated for the product that's being used, and typically those will keep it safe. So what we have here is, yep. All right, so the next thing that we're going to be talking about is we're going to talk about, okay, we talked about the bus bar, we talked about the fuse safety, protecting the wire. Yeah, so let's hop back over to the computer so I can get back to my notes and go to the next part of this video. And guys, if you're watching right now live, feel free to ask any questions. Happy to answer them. So let's go to the computer, and our first thing we want to talk about is, let's see if I can get this thing zoomed in properly. There we go. So the first thing we want to talk about is proper fuses. We're going to go back to the van. Oh, thanks Go and Do. I'm excited. We're getting closer. Spending some time working on some blog posts in this video, but we're getting to it. We're knocking things out. So let's talk about proper fuses. Go back here. So this one is pretty easy because each of the manufacturers provided me with the value for each one of these fuses. So all I did was look in the manual, go by the manufacturer's specification on the component that is either getting the power or providing the power to the system. And then I just went through and made sure that the fuses are right. Now I'll personally, as a builder, double check to make sure that if something looks weird, if maybe the fuse is too oversized and I think it would damage something, I might undersize the fuse a bit. The worst thing that's going to happen is the fuse blows and then you just have to put another fuse in there. So everything's still protected. All right, next we have proper wire gauge. And so the proper wire gauge, what I want you guys to reference is, and I'll remember to put this link in here. You type in Blue Sea Systems wire chart. Blue Sea Systems, that's a company that I use for a lot of my van builds for the electrical components. And they're going to have a chart like this. There we go. So blueseasystems.com, and then you can go in and they'll, let's see here. You'll go to the website. Let me back up. So go to the website, scroll down, and then you'll see this chart, and you can click on it, and it'll open it up in a bigger window. Now, if this looks completely wild to you, you've never seen this before, I'll make it very simple. So this chart starts with the current in the wire, and then the wire size, and then it goes up from there. So find out how much amps you need to support in the wire, and then you're going to cross-reference that with the length. So there's those three things you have to worry about. The reason length becomes an issue with wiring is the longer the wire is. So let's look at here on this right side where it says 3% voltage drop and 10%. So they're talking about non-critical and critical. Non-critical means if a device can withstand a 10% voltage drop and not turn off or damage itself, then you're over here. If you have something that's a very sensitive piece of electronic and a slight voltage drop would start to mess it up, as in the case of that refrigerator that I'm going to show you right here. I made this line too long. The gauge of this wire was too low. So if it's critical, then you go into this chart for your reference. So for example, if you had a 16, so let's use the example that I had that messed up. So I had a 14 gauge wire, and typically that 14 gauge wire can go 65 feet, and your voltage drop is not going to be enough to where if it should mess up your device. However, this piece of equipment that I was working with, this Vitro Frigo fridge, very nice fridge, very high end, the electronics were very sensitive. It didn't damage the fridge, but what it did is it created a nuisance fault because there was just, I mean, it was like 0.6 of a volt or something like, it was something very, very right on the border. But you can see, because it was a sensitive piece of equipment, the same gauge went from 65 feet to 20 feet just because of the percent voltage drop. So if you have something that is giving you kind of nuisance faults, but you feel like you have put the correct wire in, you've got the correct fuse, the fuse is not blowing, but for some reason it's not enough juice to keep it happy. So you can see the difference here, 65 feet versus 20. So I had another wire that was not used in this project. It was actually a 12 gauge wire. And so by upping or increasing the thickness, so as the number goes down, the wire gauge increases, the thickness of the wire increases. So it's kind of opposite. So from going to 14 to 12, I was able to gain 5 feet. And that 5 feet allowed me to get enough current down the wire, and it extended my length so that the length of the wire was not in question. So hopefully that makes sense. I know that's pretty detailed, but the longer the wire goes, the less current that it can provide to a piece of equipment. Depending on how sensitive that piece of equipment is if it's going to be a problem or not. Because in these scenarios, the fuse never blew. It just didn't get the adequate voltage because the run of the cable up the wall, across the van, down the van roof, down the van wall, across the floor, and back up to the fridge was just too long. So by changing it from 14 gauge to 12, it gave me the additional theoretical feet, and that solved the problem. So if you're using this chart and you're also looking at, let's look at the 12 gauge wire, for example. So we're going to go on here and we're going to type in 12 AWG max amps. And the first thing that's going to come up is 20. So 20 is the maximum amount of amps or current that this wire can hold. So as we go up, you can see we have, if we need more current in the wire, we're losing our feet with the same wire. That's why we had to go from 14 to 12, is because there wasn't enough, we lost the distance. Because you see 12 goes here. If you're going 25 feet with 5 amps through the wire, you're fine. When you go to 10 amps, it lowers to 15 feet. 15 amps, 10 feet. And then 12 would be 0 to 20 would be 10 feet. So that's a perfect world. It's not to say it wouldn't work if you went longer, but you might have that nuisance error messages like I had. But if you have a circuit, let's just say I'm making this up now. Let's just say you had a fridge that was 20 amps. If you know the fridge needs 20 amps, which is, now that's not typical, I'm just making this up. But if you have a device that needs 20 amps, you just go backwards and you say, okay, what can run 20 amps? Well, a 12 gauge wire can run 20 amps. Well, what if I wanted to save some money and go with a 14 gauge wire? So a 14 gauge wire is only 15. So this is where safety comes into play. By trying to save money, some DIY wires may run into the problem of bringing risk to their van because they tried to go to a lower cost solution. Technically, the device works. I mean, the wire is giving the voltage to run the device, but it's not safely doing it. Because if your device is pulling 20 amps and you fuse a 14 gauge wire at 20 amps, the wire is going to fail before the fuse melts or breaks. And that is where fires can occur. That's the danger in that's why some vans catch on fire, is because the wire turns into a coil like in your oven at home. No joke. Because the wire is the only thing that is absorbing or is the resistance to all that current, and it starts heating up and getting really hot. And if you've oversized the fuse to make the device run, the wire is not protected. So if you remember, when we go back over here, we've fused it correctly to protect the wire. And by protecting the wire, we're protecting the van and the device. That is why it's important to have proper wire gauge. And then let's look at proper wire and component shielding. And we're going to go in the van. Here, I'll show you the chart here. So we're talking about proper wire and component shielding. So if you look here, this looks like a professional install. We've got really nice thick jackets here on the cable. So we've bought a high quality cable. We've used heat shrink to minimize, it helps with corrosion and moisture getting inside the terminal, or the battery lug. And it's also making sure that there's nothing that can accidentally arc this positive part. So we get it as close to here as possible, and that's good. We also got the proper fuses for this device. So just because you have this, you got to make sure that you have the proper fuses. So for this one, it's a Mega Fuse is the name of it. But let's just say something really bad happens. I don't know, this inverter fails and something pops, but it's a little bit more violent. So this cover is to protect anything from not only touching it or arcing it, but if whatever happens inside here. So if there's like a little burst or like a little mini spark, it's contained in this cover, and it's not damaging anything else in the van or potentially shorting anything else in the van. Hopefully you're not going to have that much current to where that's happening, but this 2-watt cable right here, it's a lot of current. You know, it's maximum of 300 amps before it actually fails. So there's 300 amps of current in this one wire. So make sure your wires are protected. You don't have any nicks or scrapes in the wire, and it's the wires are in good condition. You're not taking zip ties and cutting into the wire, or you're bending the wire in some corner, or you're forcing anything. You know, stuff is laid out and it looks professional. All right, this is our second part of the video. Wiring your power system efficiently. So we talked about wire length. Wire length, we don't want to get ourselves into the, so the wire length here has to do with, let's see, battery charging. If you want to do something, we'll come to this drawing in a second, but in a perfect world, if you had, let's say you had a battery bank, and let's change colors, and we're going to do 4 batteries. So you got 4 batteries. In a perfect world, you want all of your, let's see here. Let's draw it like this. So we're going to do like a 400 amp hour system. Now this is perfect world right here. So in a perfect world, we're going to use the blue thing here. You would want to connect, actually I'll do red. You want to connect all the wires connecting the battery. You want these all to be the same length. Okay? Because you want the current distributed to them evenly. So if you have your power cable coming in, so this is your positive coming in, the length of that one, again, this is perfect world, is going to be equal coming in, and then the next one is you want it, if possible, you know, equal coming out. So when you ground it. Now some people will, it's not completely wrong, this doesn't really hurt anything, but if this is your power coming in, this battery gets charged first, and then the power has to get all the way down to this last battery last. So that's why it's important to, and this will work, but in a perfect world, the length here and the length here would provide the best charging for your batteries. Because what's having to happen is the power is coming into here, and then over here it's coming into here first. So you've got this Gotta make sure I'm drawing this correctly. This is just a better way for the power to flow. Now, I understand if you're in a tight spot and you can't do that and you have to do it like this, to where this is the positive coming in the negative. With a heavy enough gauge wire here, that might not be an issue. Some people actually, and some other YouTubers that do electrical info, they might connect this with a solid piece of brass, copper, like a bus bar, and that works out good too. You just want to make sure that you're evenly pulling power and putting power back into the batteries if possible. So if you have a wire here that's this long and then a short wire and then a really long wire, that's not optimum. That's what I'm saying. And so that's wire length as far as it goes with battery charging. Wire location, this is what I was talking about with voltage drop. So let's go back to our drawing pad and we're going to go to the previous drawing that I'm going to finish. And so right here we have a circuit where, let me use this purple one to show you what I'm talking about. So we've got a battery here. We've got a terminal fuse protecting the cable that is pulling the power from the battery to the disconnect. And then we have the disconnect to the bus bar. And then we have our fridge. And so what are we missing here? We're missing a fuse. So let me get the purple stuff out of the way. All right, so we got a fuse here. It's not what a fuse looks like. I'm just saving time. So we got a fuse. And so now let's go ahead and finish this circuit. So we need to turn the fridge on and off. So we need to pull a positive wire here. And we need to have two things. So one, we're going to put a switch in here. So we've got a switch to turn it off and on. And then we got a fuse to protect the wire. So this is, we're going to put a green box around here. So this one is protected. The question is, what is the maximum fuse that we can put in this if this is a 12 gauge wire? And so we'll just hop on over to our, if I can find my mouse. Let's go to our computer. And so we got 12 gauge wire. I'm actually going to go to a different, let me get some different info here. We're going to type in fuse size calculator, and there's no affiliation. This is not sponsored, just easy information for you guys. But the first one that pulls up is Explorus.life, and if you've looked at his channel on YouTube or website, he's got some cool calculators that help you with getting the appropriate fuse size and stuff like that. So the device amps, let's say we've got 15 amps. The fridge is, let's say the fridge is pulling 15 amps, 12 volts. And the wire size, we're going to do 12. And let's make this 20. Just kind of show you guys the difference. So 20, 12, it spits out 20 as the minimum fuse size. Well, that's correct because that is the lowest we can go and still protect, or that's the highest we can go and still protect the wire. So over here, by default, we could put in a 20 amp fuse. Now where it changes is we need to find out what the manufacturer suggests for this circuit. So if this device needs no more than 15, we'll bring this down to 15. So that's kind of how you do that. And then one thing we forgot is we're going to take our ground and connect it right there. So the I think I had some audio coming through. Sorry about that. Yeah, let me know if you guys heard that the whole entire time on this video. I might have to redo the video. Pause 1 second. Let me hop over here. Okay. So that last question we were trying to answer was this the wire location voltage drop. So right here, we need to make sure that this cable, we need to make sure that these lines, especially the positive, is not too long and it's within the specs of our chart over here. This chart. All right, and then last but not least, we're going to talk about to ferrule or not to ferrule. So if you have any type of device where you have the screw down, the little tiny, but let's see if I can find an example really quick. Basically, if you have something that you need to screw down in a tight space, we're going to use this for example. So if you have something like this, and you have some bolts, and they have a little size where you need to get a wire in, but you don't want to have the frayed wire, and you don't want to twist it and get it in there because it might bend and break off. This is where you need to buy a wire ferrule kit, and this is on the, you guys can find this on the DIY VanBuild cheat sheet, which we'll talk about in just a minute. But this wire ferrule kit comes with all these ferrules. And what they do is they will take your wire. So you're going to have an exposed wire like that. And then you pick the appropriate gauge ferrule. And you guys can see what that does is it makes the wire nice and neat. And then you're going to take a crimper like this. You put it inside the crimper. I'm not going to do this because I'm not ready to do it on here. But you're going to crimp that down, and then that's going to allow you to plug it into wherever you need to, and you're not going to have to worry about the wire breaking off. It makes the circuit really nice and safe. There's also there's like 7 gauge and 10 gauge ones. These are perfect for inverters or shore power, stuff where the wire is much thicker and you need to stuff it into an inverter, which is usually like a screw down clamping device. This is what you want to use. Make sure that connection is really safe. All right, guys, I'm going to call it, that is it for the video, but make sure you guys check out the DIY van build cheat sheet. If you guys don't know what this is the last 3 years of my Amazon purchases, and I've put it into an organized, curated list of over 250 items. Electrical, we've got HVAC, fasteners, stuff that I do for 80/20, roofing, stuff like the roof seals, solar, such as Renogy devices, and then the most important is tools. So this tool list, which is actually the blog post right here that we are actually talking about, wire strippers, crimper combo, ferrule crimper, screwdriver set. So the stuff that's related to this video, everything is in this DIY van build cheat sheet. The best part is it's completely free. All you gotta do is put your name and email address. It'll go straight to your inbox. And this sheet is a ever-growing sheet. Anytime that I have more products that I want to put on it, we add to it. And so it's a living document. It's going to grow with over time with more products. But if you're a DIYer and you're wanting to approach a van build, and if I could have a list that I could just check off, 10 or 15 tools and say, hey, Nick said these are the best tools to get me kick-started on my build. That way I'm not running into Lowe's or Harbor Freight 100 million times. They're on this list. So just download it. It's completely free. You'll see the crimpers, the hydraulic crimpers that I use, the Rivnut gun right here. This is what I use to install the Adventure Wagon system. But really, if you need a threaded stud within your van crimped, this is the tool to get. It's off Amazon. Good price. But all of that stuff is put together in a curated document for you right here, completely free. Sign up for it. I think you guys will really enjoy it. And then last but not least, I want to talk to you guys about Odyssey Custom Vans. So Odyssey Custom Vans is my van build business. So that's where all this content comes from, and the van behind me is officially for sale. So I just wanted to hop over here on the website and kind of walk through a couple things really quick to see if you guys, or just to show you what's on here. So updated the website to include some pictures of the van. The van is for sale, but we haven't actually done the final walkthrough. We have to do the plumbing system, finalize that as far as hooking up the heater. And if you guys are watching in real time, we've been doing that for a while, but got some other things going on. So in the meantime, I wanted to get photos to you guys so you could go through, get excited about the build. And if you go on the website, there's a video that I did a walkthrough at the Adventure Van Expo. So we took the van that's behind me to Adventure Van Expo, had a lot of people look at it. We had a lot of subscribers come out, which was unbelievably cool. And we went through the van, did a quick tour to get you guys excited about the finish of this van, because we're super excited about the way it looks, and that we're getting close to finishing it. So to get you some photos in the meantime, I put them together on the Odyssey Custom Vans website. You can see where we're at this point as far as everything that's been installed, the options that are on here. So above here, we've got all the detailed options that are in the van. And then there's some really cool photos of all the components within the van. And if you guys are interested in purchasing this van, or you're looking to do a custom build through Odyssey Custom Vans, this is the best way to contact me. So you're just going to go to sales at Odyssey Custom Vans. That's my email. This is our phone number. The easiest way is to click here. It's going to pull up a calendar link where you can book a time to meet with me. If you're local, I'd love to have you guys come by the shop, or you can schedule a phone call with me. Just click a time. For example, let's say next Monday here, all open. You can click on a time that works best for you, and it goes right on my calendar. There's a couple other things over on the left-hand side, just to double check, be prepared for before the call. And that's it. Book your call. You can chat with me, and love to show you the van if you guys are interested. But that's going to do it for the live stream today. Hope you guys learned a little bit more about electronics in a van, keeping everything safe. If you have any questions, put those in the comments below. Make sure you guys are subscribed to this channel. Check out all the videos. We've got tons of tours from the Adventure Van Expo. We've got van tours. We've got product reviews. All that stuff is on the Van Builder YouTube channel. And then vanbuilderhq.com is going to have all our blog posts, articles, and information for you guys that'll help you with your van build. Also, don't forget to like this video, share it to anybody who needs help building their van, and that this might be good to have and send to them. Other than that, I'll see you guys in the next live stream.